Properties of the trig functions. Properties of trigonometric functions. A lot of these can be derived, obviously, from the unit circle. This is why I stress the unit circle so much in my classes. A function is called periodic if there exists a number that you can add to the argument that keeps it the same. So in a circle, there's a really obvious initial period of 2 pi, right? Or 360 degrees if you think of it in degree mode still. Because if you add 360 to an angle, remember you get coterminal angles, and the coordinates are not going to change. However, cool little thing that happens with tangent that's special is that tangent doesn't need to go all the way around the circle. If you go here, call the coordinates of that xy, if you rotate around half a circle, right, in other words add on a pi, you have the coordinates of negative x, negative y. And since tangent itself is the ratio of y to x, that means that positive over positive is positive, negative over negative is positive, and so you only end up having a period needed of pi. Okay, so you'll see that the periods of sine, cosine, cosecant, and secant are all 2 pi, or 360 degrees. Tangent is a little exceptional because you only need to go half a circle. It's got a period of pi. Domain, what are you allowed to put in? We already talked about this in a previous lesson, that all real numbers can go into sine and cosine. With the tangent and with the secant, where you're dividing by cosine, you can stick in any real number, but not odd multiples of pi over 2, because the odd multiples of pi over 2 would stick you at tops and bottoms and cause you to divide by 0, right? Because the coordinates here, for example, are 0 over 1, 1 over 0 wouldn't work. Equivalently, you can't do the cosecant or the cotangent of multiples of pi, because in those cases, that's where the y coordinates become 0. Okay, as far as range, remember that the sine and the cosine are the x and the y values, and since we're stuck in a unit circle, you can get as high as 1 and as low as negative 1, but you can never exceed those. So that's why the domains and the ranges of sine and cosine are negative 1 up to 1. This shouldn't be too shocking if you think about SOHCAHTOA, though, right, too? Because the SOHCAHTOA would have, the hypotenuse is always longer, so you're not surprised you're getting numbers less than 1. Now it's maybe a little shocking they're also on the negative side, though. And now you can actually hit 1 if you're quadrantal. The range of the tangent, since you're dividing by numbers that get as small or as big as you want, it actually has an infinite range from negative infinity to infinity. There's a misprint. I got to do a push-up. As far as cosecant and secant go, well, I should put the negative here as well. But the cosecant and secant are exceptional because, remember, they're reciprocals of sine and cosine. And if you reciprocal a number that's less than 1, it's always going to be bigger than 1. So what's interesting about them is that they miss the numbers from negative 1 to 1, but they hit everything else. How do we use these properties to our advantage then? Well, other than just using unit circle and figuring out where this number is, the periodic property allows me to add 2 pi to a negative 11 pi over 6. Remember, 2 pi is the same as 12 pi over 6. And so sine of negative 11 pi over 6 is essentially the same as just asking sine of pi over 6. Pi over 6 right there, its y coordinate is small, that's a half. Cosine of 5 pi, remember the period of cosine is 2 pi, so if I subtract 2 pi, 3 pi is the remaining. If I subtract another 2 pi, pi is remaining. I just keep subtracting 2 pi because that's the periodic property, the periodicity. And now cosine of pi, that's no big deal. I know that pi is located right there. Its cosine value is negative 1. Tangent of 5 pi over 4. 5 pi over 4 is located technically down here. But remember, the period of tangent is only pi. So I can actually subtract a pi or a 4 pi over 4 from this angle and say this must be the same as tangent of pi over 4. Tangent of pi over 4, rad 2 over 2 over rad 2 over 2, or in a number over an identical number, is of course going to be positive 1. fill in this table here. In the first quadrant, sine is positive, cosine is positive. So therefore the tangent is positive, because tangent is sine over cosine, and reciprocals will thus be positive. In other words, all functions are positive. In quadrant 2, the sine, the y value is positive, but the cosine is negative, which means the tangent, which is a ratio of positive to negative, is going to be negative. But then remember that the cosecant is reciprocal sine, secant is reciprocal cosine, cotangent is reciprocal tangent. In quadrant 3, as far as the sine and cosine function goes, they're both negative, but negative divided by negative is positive. So minus minus plus, minus minus plus. And in the last quadrant, we have plus minus, so cosine is positive, sine is negative, the ratio is negative, and that fills in the last slots. In class, I like to label these with all trig functions are positive. Thinking of the three major functions in quadrant 2, sine is the positive one. In quadrant 3, tangent is the positive one. And in quadrant 4, cosine is the positive one. And you can remember the mnemonic, all students take calculus. So name the quadrant in which the angle lies. Cosine is positive in quadrant 1 and in quadrant 4. Sine is negative in quadrant 3 and quadrant 4. So which one satisfies both? Must be in quadrant 4. Cosine is negative in quadrant 2 and 3. Tangent is positive in quadrants 1 and 3. Therefore, this angle must be in quadrant 3. Finally, cosecant, which is the reciprocal of sine, would be positive in quadrants 1 and 2. Cosine is negative in quadrants 2 and 3. Now I must be in quadrant 2. So I have to give you a couple pieces of information to determine which quadrant you happen to be in. Okay, let's find the values of these then. So we know that we have an angle that's located in quadrant 2. We know that the cosine of that angle is the, again, I'm going to do unit circle type way, which is my brain. So I don't mind putting a -3 there. Hypotenuse is 5. Pythagorean theorem would dictate that this last side is 4. And so if I need to do the sine of theta would be opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Cosecant of theta is a reciprocal. Secant is a reciprocal of cosine. And cotangent is a reciprocal of tangent. Next, cosecant of theta is 3. Remember, that's 3 over 1. Cosecant is positive, so I'm either in quadrant 1 or 2, because it's a reciprocal of sine. Cotangent is negative, so I'm either in quadrants 2 or 4. And that gives me enough information to say that I must be in quadrant number 2. Cosecant is the hypotenuse over the opposite. So there's my hypotenuse. There's my opposite. 9 minus 1 is 8, and square root of 8 is 2 rad 2. So that's how I get my angle, or my third side of the triangle, Pythagorean theorem. And now I can do all 6 trig values. Sine theta is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Cosecant is reciprocal. Secant is reciprocal. And then cotangent is reciprocal. Make us do it again. Well, let's pause there for a second in case you need to pause the video. Do it again. Cotangent is positive. Tangent is positive in 1 and 3. Cosine is negative in 2 and 3. So we need to now draw an angle that's in quadrant number 3. Cotangent is the ratio of the adjacent over the opposite. Adjacent over opposite. And since I'm in this quadrant, both of these are negative. And that means that this side would be 5. This is a 3, 4, 5 triangle. Sine theta is then negative 3 over 5. Cosine theta is negative 4 over 5. Now you're done, right? Tangent theta is the ratio of those. And then you have reciprocals. Negative 5 over 3. Secant is negative 5 over 4. And the cotangent is the 4 over 3. Last example here. Cosine of theta is positive. Means I'm in quadrants 1 or 4. 3 pi over 2 is at the bottom. 2 pi is over here. So they're actually telling me. I didn't even need to do that first part. I just am told I'm in quadrant number 4. So if I draw this triangle in quadrant 4, the cosine is the adjacent over the hypotenuse, which means by the Pythagorean theorem, this is 3, 4, 5 again, but I'm in quadrant number 4, so that's a negative distance because I think of the coordinate down here. And so last set, sine of theta is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is the ratio of those two. Cosecant, reciprocal. Secant, reciprocal. And cotangent, reciprocal. That completes this problem. Okay. There are more properties for us. Even odd properties. So remember that when you're working with an angle, or with a function, sorry, f of negative x is equal to f of x is an even function. And if you think about what's happening on with angles in the unit circle, if the coordinates here are x, y, and that's theta, then your negative angle's down here, and it has coordinates of x comma negative y. So you might notice that the x's are the same, whether you use a positive angle or a negative angle. And so this is going to imply that cosine is an even function. What happens with the y coordinates? Well, they're the same number, but they're opposite SIGN, which means that functions like sine are going to be odd functions because f of negative x equals the opposite of f of x. So let's summarize those properties down here. Sine is odd. Cosine is even. The reciprocals work in the same way, so cosecant's going to be odd. Secant's going to be even. As far as the tangent, it turns out that when you take a odd divided by an even, you're going to get a negative sign floating around. So this one's also going to be odd. And the functional property they're referring to then is that just means whenever you take the sine of the opposite of an angle, it's going to be the same as the opposite of the sine of the positive angle. When you take the cosine of a negative angle, that's just going to be the same as the cosine of the positive angle. Tangent of a negative angle is going to be opposite of tangent. Cosecant of an opposite angle is going to be opposite. Secant of an opposite angle loses the negative sign, being even. And finally, the cotangent of a negative angle is a negative cotangent. This was supposed to go up there. Note to self, I gotta fix that. Okay, let's use these properties to calculate some values then. So cosine of negative 30 degrees by the even odd properties is the same as cosine of 30. And from unit circle, I know that cosine of 30 is equal to radical 3 over 2. This is going to, sine of negative 135, sine is odd, so this will be negative sine of 135 degrees. 135 degrees is this monster here, whose sine is rad 2 over 2. So this will be a negative rad 2 over 2. cosecant of negative 30 degrees is going to be the same as the opposite of the cosecant of 30 degrees. 30 degrees is here, has a sine value of 1/2, so it has a cosecant value of 2, making this negative 2. Sine of negative pi over 3 is going to be negative sine pi over 3. Pi over 3 was the one located here with a rad 3 over 2. Secant of negative pi, this one's a little bit interesting, I guess, because we're going the opposite direction, but it still lands over here. And that would give me a negative 1. Oh, they wanted us to use even odd properties, I'm sorry. Secant of negative pi is the same as secant of pi because it's an even function, which means I'm interpreting it as over here, which gives me a negative 1. That's a good mistake to make, though, because it shows you it doesn't really matter how you interpret them. You just have to be consistent and follow the rules for however your interpretation is. And this last one is negative cosecant of pi over 3. Pi over 3 is here. Its sine is rad 3 over 2, and so this is going to be a negative 2 over rad 3. Okay. Couple more advanced problems using some of these properties then. Cosine of theta equals 0.2. Find the value of cosine theta plus 2 pi, cosine theta plus 4 pi. 4 pi. Notice 2 pi is a period. 4 pi is just 2 periods. So this is the same as saying cosine theta plus cosine theta plus cosine theta. 0.2, 0.2, 0.2. That's just a 0.6. Find the exact value of sine of 1 plus sine of 359. Again, awkward numbers, which usually means it'll be useful for us to look at a unit circle to think about this. One of them's here and one of them's here. Those values are going to be opposite each other. So if I wanted to convince somebody that I knew what was going on here, I would say sine of 1 degrees plus, right, like a proof here, sine of negative 1 degrees. That's by a period property, because I subtracted 360. Then I could go sine 1 degree minus sine 1 degree. There I'm using an even odd property because I pulled out the negative. And then, of course, a number subtracted by itself is 0. But again, I'm anticipating that already just by knowing my unit circle. I knew that this was going to cancel out and become 0. Pythagorean identities. The Pythagorean identities come from the unit circle because the equation of a unit circle is x squared plus y squared equals 1. But now that we know that the x is the cosine of theta and y is sine of theta, this means that sine squared theta plus cosine squared of theta also equals 1. This isn't shocking by the SOHCAHTOA definition as well. Now, to get these other ones, they actually follow from this one. If you take sine and divide by cosine, that's tangent. Cosine divided by cosine is 1, and 1 over cosine is secant. So rule number 2 comes from rule number 1 divided by a cosine squared. And rule number 3 comes from rule number 1 divided by a this would be by a sine squared, because sine squared over sine squared is 1, cosine squared over sine squared is cotangent squared, and 1 over sine squared is cosecant. I think in the future I'm going to go reverse those so I can draw the analogy much easier. Besides these Pythagorean identities, motivated by the fact that there's something squared plus something squared equals 1, we have other identities called reciprocal and quotient, but they come from the unit circle definitions, essentially. Cosecant is 1 over sine, that's called a reciprocal identity. Tangent is sine over cosine, that's called a quotient identity because you're dividing things. This is an example of a quotient. That's an example of a reciprocal identity. So let's calculate some values. Last 4 problems. What is sine squared of 16 degrees plus cosine squared of 16 degrees? That's 1 by the Pythagorean identity. Sine squared plus cosine squared of anything is just simply 1. Here, tangent of 10 degrees. Cotangent is 1 over tangent of 10 degrees. This is by reciprocal identities. And a number divided by the same number is also 1. Here, cotangent of 20 degrees. Cosine over sine is cotangent. That's by a quid, or a quotient identity. Cotangent minus cotangent is 0. And our last example here is the secant of negative pi over 18. I'll change this into the secant of pi over 18. That's using an even-odd identity. Here I'll subtract 2 pi. 2 pi is 36 pi over 18, so I'll subtract 2 pi to call that one cosine of pi over 18. And that's using a period property. And then I'll rewrite the secant as a 1 over cosine of pi over 18 times cosine of pi over 18. And in that step, I'm using what's called a reciprocal identity, right? Secant is 1 over cosine. A number divided by itself then yields 1. And that completes the day 3.